All right, number 6, just a little bit ahead of time on this one. There are a lot of parts. We're not going to let the parts scare us. We're going to just try to weed through the little directions. There might be some parts that are a little bit harder than others, but I think if we just try to use clues in the problem, we can make this problem easier than it may seem. All right, a function has derivatives of all orders between -1 and 1. The derivatives of f satisfy the conditions above. The Maclaurin series for f converges to f of x equals 1 for any values where the absolute value of x is less than 1. So A, show that the first 4 non-zero terms of the Maclaurin series for f are x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4, and write the general term of the Maclaurin series for f. So the first thing they want us to verify that these are the first 4 terms, and then to write the general term. Just an FYI, I could totally just do part 2 without doing part 1 if all of this wordiness was giving me issues. So again, we're just going to treat the problem in isolation and not get worried about parts we might get confused on. But here we go. Okay, if I want to write first 4 non-zero terms, if you recall, it's a Maclaurin series, so it's about f, it's about 0. So we know just in general that we're going to have f of 0 plus f prime of 0 x plus f double prime 0 x squared over 2 factorial plus f triple prime of 0 x cubed over 3 factorial plus f to the 4th derivative of 0 x to the 4th over 4 factorial, and I could keep going. So now what we want to do is use this to show that if I use these conditions, I'm going to get this as an answer. All right, so first of all, I'm just going to get started. F of 0, they told me is 0, so that didn't help me because I need 4 terms. So then plus, so that really doesn't count as a term. F prime of 0, they told me is 1, so this is just going to be 1x. So far I have verified that first term. That's really nice. Okay, and now from here, we just want to continue verifying. So I am going to, now they don't tell me any of those other derivatives, so I need to go find them. Okay, so to get the second derivative at 0, what I am going to do, notice if I want the second derivative right here, I want this to say 2. The n would have to be 1. So this is really f of 1 plus 1 of 0 is equal to negative n. Well, I've already established that n would have to be 1. So it's going to be negative 1 times f to the n, which is also 1. So the first derivative at 0. So to get this, I'm going to put negative 1 times the first derivative at 0 is 1, which is equal to negative 1. So f double prime is equal to negative 1 x squared over 2 factorial, which is 2. So notice I've now verified that second term. Good for me. Okay, so now we're going to find f triple prime of 0. So if it's something plus 1, this time it's going to be f of 2 plus 1. So this time my n is going to be 2. So it's going to be negative n is 2, times f, n was 2. So it's the second derivative at 0. Well, we just found out the second derivative was equal to negative 1. So we're going to have negative 2 times negative 1, which is equal to 2. So the second derivative of 0 is equal to 2x squared over 2 factorial. And if I simplify that, I'm guessing, whoop, I did the wrong one. I'm on the 3rd factorial. Sorry about that. So the third derivative is 2x to the 3rd over 3 factorial, and I can simplify that in a minute to show that it actually is the right term. Okay, and then we need 1, 2, 3. I need one more term. So from here we need the 4th derivative, so I'm going to do that exact same thing. So I'm going to do the 4th derivative of 0, which is equal to f of 3 plus 1 of 0. So n is 3 this time, so it's going to be negative 3 times the 3rd derivative of 0. And so I'm going to get negative 3 times, we already found out that the 3rd derivative of 0 at 0 was 2, so this will be negative 6. So from here, my 4th derivative was negative 6 x to the 4th over 4 factorial. So now I just need to clean it up. So I'll get rid of my 0. So I'm going to have 1x minus x squared over 2 plus 3 factorial is 6. 2 divided by 6 is x cubed over 3. And then minus 4 factorial is 4 times 3 times 2 times 1, which is 24. and then 6 divided by 24 is 4, so we're going to do x to the 4th over 4. So notice I have now verified those first 4 terms, okay? The next part of it, so that was part 1. Part 2 was to find the general term. So even if you couldn't do what I just did, look at this pattern right here. What's happening every time? When n was 1, n was 2, n was 3, n was 4. To get the general term, it's just going to be x to the n over n. And then I just need to decide when is my positive and negative happening. And this is going to be, I should have left myself more space, negative 1 to the n plus 1. Because when n was 1, it was not negative. I'd have to add, I have to have to the n plus 1 in order to make my negatives be in the right spots. So that's what that would have to do with, and then I would be set. So that is my formula. That would be my general term. So I get, let's see, how many points do I get? Oh, I got 3 points. Okay. If I was able to find all of these derivatives up here, I'd get a point. If I was able to verify my terms, I'd get a point. And if I were to find the general term, I'd get that 3rd point. Okay, part B. We're going to have a little difficulty if we didn't find the general term in part A. So hopefully we were able to do that. Determine whether the Maclaurin series described in part A converges absolutely, converges conditionally, or diverges at x equals 1. So if you recall, the general form looked like this. Okay, we're trying to decide how does that converge, and it says at x equals 1. So I'm going to put 1 in there. So I'm really going to end up having negative 1 to the n plus 1 over n. And I'm trying to decide how does that converge. It's an alternating series. So the first thing I want to do are my 3 alternating tests. First of all, are all of my terms, this would really, remember my b sub n would be the 1 over n, the part that's does not have the the negative on it. So 1 over n. Are all of those terms positive? Yep, so all terms are positive. 2, are the terms decreasing? If I took the derivative of that, I'm going to get negative 1 over n squared, and that will give me a number that is always negative, so I know all of my terms are decreasing. And my 3rd test is the limit as n approaches infinity. If I let n approach infinity, I will get 0. So it does meet the terms of the alternating series test. So we know it converges somehow. So I'm going to put converges. We just know it converges either conditionally or absolutely. So now I'm going to go to my absolute convergence test, which would be negative 1 to the n plus 1 over n. And I'm going to say, if I looked at this and I ignored that would end up being 1 over n. 1 over n is going to be a p series, and p is less than or equal to 1, which means this series is going to converge, it's going to diverge, yes, that is correct. So it's going to diverge, so we know it converges conditionally. So it converges conditionally, and it asked us to say why. It's going to converge conditionally because it meets, as I showed, it met all 3 terms of the alternating series test. However, when testing for absolute convergence, 1 over n was a p series which diverges. So hopefully that kind of all made sense, and maybe you could write a little bit more about that. So we are going to get 2 points for that one. We get 1 point for saying it converged conditionally, and 1 point for a nice explanation. All right, part C, Write the first 4 non-zero terms and the general term of the Maclaurin series for g of x is equal to the integral of this. Okay, so first of all, if you did absolutely awful on all the other parts, we can still just regroup. Okay, we already have the first 4 non-zero terms of the formula for f. So let's just go ahead and write those down. It was x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4. Okay, if you had the bonus, and maybe hopefully you had this, but if not, don't worry about it. Okay, that was my general term. So now it's asking me to take the integral of this. So all we need to do is just take the integral of every single term. So again, even if you didn't have a clue on part A or part B, just go back to those 4 terms that they gave you, and it just says to take the integral. So here we go. So we're going to get x squared over 2 minus x cubed over 6 plus x to the 4th over 12 minus x to the 5th over 20. So I'm good to go, I think, so far here. And then from here, if I take the integral of the next part, remember x is the only constant in this problem, so the negative 1 to the n plus 1 just comes along for the ride. I increase my power by 1, and then I'm going to have an n times the new power. So that would be my first four non-zero terms and the general term. Okay, I got 1 point for finding the first two terms. I got 1 point for finding the second two terms, so hopefully I could get 2 points just really from not knowing much, and then I'm going to get 1 point for getting that general term. And again, if you didn't have the general term, you're going to have a hard time getting that point on that one. Okay, part D. Let P sub n of 1/2 represent the nth degree polynomial for g about x equals 0, evaluated at x equals 1/2, where g is the function defined in part C. Use the alternating series error bound to show that the error, this is what this is talking about, the error between the polynomial and the actual function at 1/2 is less than 1/500. Okay, so this is an alternating series error. If hopefully you recall, with an alternating series error, you just need to find the next degree term. So if I have the fourth degree polynomial, and I'm going to rewrite it from, because it said to take it from part C, it was x squared over 2 minus x cubed over 6 plus x to the fourth over 12 minus x to the fifth over 20. If this is a fourth degree Taylor polynomial, okay, right here, there's a little 4 there, okay, to get the error, I just need to use the fifth degree term. So we are going to use the fifth degree term. I'm going to use it at x equals 1/2, and we're going to go ahead and put it in absolute values because we don't care how we are on the values. So it's going to be negative 1/2 to the fifth over 20, which is equal to 1/32 over 20, which is equal to 1/32 times 20, which is equal to 1/640. Well, how that turned out, 1/640, which is less than 1/500. Okay, so that is all we need to do. We found that error bound that was worth 1 point. So 6 is done.